Okay, an open glass-topped aquarium with a square base is designed to hold 13.5 cubic feet of water. What's the minimum surface area of the aquarium? What you're trying to do here is you're trying to save money. Build something. You're told that some company says, hey, we want these aquariums for the fish. We want them 13.5 cubic feet of water. Okay, and we want them a square base. And you're going, well, I want to build them so there's the least amount of glass possible so I can save the most money so I can make the biggest profit possible. Calculus allows you to figure out how to do things like that. So, in the end, you want the surface area, but right now you're given the volume. The volume equals, on a space like this, the base, the area of the base, times the height. So it's the side times the side, or the side squared times the height. Okay? The surface area equals the area of the base, the side squared, plus the area of each side. There are 4 sides, and they're all S times H. Okay? So, we want to minimize the surface area. We're given the volume, 13.5 equals S squared H. So is there a way I can write the volume in terms of surface area? Or, see how these have 2 variables? I want to get them down to 1. To get them down to 1, what should I get alone here? If I get H alone, then I plug in the H there. Now I'm down to 1 variable over here. So my surface area equals S squared plus, what's 13.5 times 4? 54 over S, right? Okay, now there's my equation for my surface area. S squared plus 54 over S for this container. I want to find the minimum surface area. So I want to find the critical number for this, the critical number for S. To find the critical number, I take the first derivative, which is 2S plus, and this is 54S to the negative first, so it'd be a negative 54 over S squared. Because if this is up here, this is S to the negative first. So negative 1, 54, S to the negative second. Okay? What do you do to find a maximum or minimum? You set your first derivative equal to 0. Set your first derivative equal to 0. So 2S equals negative 54, or positive 54 if we move it to the other side, over S squared, multiplied by S squared. So 2S cubed equals 54, divided by 2. S cubed equals 27, so S must equal, what's the cube root of 27? 3. So if you make your sides each 3, 3 times 3 is 9. 9 times what is 13 and a half? What's 13 and a half divided by 9? 1.5. Exactly. So, what is a surface area of this? Well, we can just plug it into here. Surface area equals 3 squared plus 4 times 3 times 1.5, or 9 plus 12 times 1.5 would be 18. So surface area is 27. That's what the surface area happens to be at a minimum. Okay, so if you build it 3 by 3 by 1.5, you're saving the most money possible in building supplies. A piece of paper display 150 square inches. A piece of paper is to display 150 square inches of text. If there's a 1-inch margin on each side and a 2-inch margin on the bottom, what are the dimensions of the smallest piece of paper that can be used? Okay. So here's the text. So you have a 1-inch margin here, a 1-inch margin here, a 1-inch margin here, and a 2-inch margin here. Okay, so we don't know what either of these is, but here's an X and here's a Y, kind of base times height. I know that X times Y equals 150, correct? Because this has to have this much text. Okay, so my new width is X plus 2. My new height of this is Y plus 3. So the area of the paper in the end should be X plus 2 times Y plus 3. You all right with that? 1 inch at the top, 2 inches at the bottom, Y high. So Y plus 1 plus 2 is Y plus 3. So we need to get rid of one of these variables here. So how can I get rid of it? Well, I take my original equation and divide them both by. Doesn't matter. You could divide by X or Y. I'll divide by X. So Y equals 150 over X. So then what we're going to do is replace our 1Y with 150 over X. So I want a minimum area. So I have to FOIL this out. I wouldn't have to FOIL it out, but I'd rather FOIL it out than use the product rule. So 150 over X times X is 150. Outers is 3X. Inners is 300 over X. Last times last is 6. So the area equals 3X plus 300 over X plus 156. What's the first derivative of the area going to equal? 3 minus, or 3 plus a negative, 300 over X squared. So it equals 0. 3 equals 300 over X squared. 3X squared equals 300. Divide by 3. X squared equals 100. X equals 10. So if X equals 10, this is 10, so this is 12. Plug it in. What's 150 over 10? 15. So the height of the paper is 15. So the Y plus 3 is 18. So a 12 by 18 paper would be the smallest you could have. Okay, so you're going to have two equations. You're going to combine them into one. You're going to take the first derivative, set the first derivative equals 0, and that'll be able to find your minimum or maximum. Let's do the same type of thing. At a restaurant, the daily menu is posted on a wallboard. The printed region includes 216 square inches of text. There's 2 inches margins on each side and 3 at the bottom and top. So there's 216 inches of text here. This is X, this is Y. There's 2-inch margins on the sides and 3 at the bottom and top. So there's 3 here, 3 here, 2 here, 2 here. So what is the big piece of paper? X plus what? X plus 4. And then the height is Y plus 6. So your original X times Y equals 216. And your new one, the big paper, is X plus 4 times y plus 6 equals your new area. So if you say y equals 216 divided by x, you just replace your y with 216 divided by x. What's our next step? Because we just did a problem just like this. FOIL. So x times 216 over x is 216. Outers is 6x. Inners is, that would be 864 over x plus 24. So the area equals 240 plus 6x plus 864 over x. Now you take the first derivative. So the first derivative equals 6 plus a negative or minus 864 over x squared. So that equals 0. So 6 equals 864 over x squared multiplied by x squared. 6x squared equals 864 divided by 6. X equals 100. 144? Perfectly. Boy, these numbers work out really nicely. X equals 12. So the original was 12, so the new is 16. If you stick 12 in for this, what's 216 divided by 12? I have no idea. 216 divided by 12. 18. So y is 18. 18 plus 6 is 24. So it's a 16 by 24 wallboard. Okay, so I have 12. So I put the 12 in for the x right here. And then the wallboard, because this is the text and this is the wallboard. So 12 plus 4 is 16. And then I know that x times y equals 216, so y equals 216 over x. So I take 216 divided by x, which is 12, and I get 18. So the text is 12 by 18. So then the wallboard is y, which is 18, plus 6, which is 24. All right. A function is defined as that. What is the x-coordinate of the point on the function graph that is closest to the origin? All right. So here, we're talking about closest to the origin is how far it is from the origin. How far something is distance. Okay? So, the origin is here. The distance is here. The distance formula can be used, or the Pythagorean theorem can be used. Okay? So, all right. So, we're looking for what is the x-coordinate of this to make this. Okay. So, the origin is 0, 0. This coordinate is x, comma, y, which is 2 square root of 9 minus x. I think I'm going to use the distance formula here. I think so. So the distance formula equals the square root of x2 minus x1, this minus this, x minus 0, squared, plus y2 minus y1 squared. So the distance formula equals the square root of x squared plus, if we square this, we get 4 times 9 minus x. So it's the square root of x squared minus 4x plus 36. Okay? So, closest is minimum, right? So to find the minimum, we have to do the first derivative of this bad boy. So my distance is x squared minus 4x plus 36 to the 1/2 power. So the first derivative is, oh, not enough room. Let's go over here. First derivative is 1/2 times this to the negative 1/2 power times the first derivative of the inside. So if we do that, 1/2, if we distribute it through 2x minus 4, we get x minus 2. So it's x minus 2 over the square root of x squared minus 4x plus 36. So that your first derivative equals 0. How do we solve for this? Multiply by my denominator. What happens? It disappears. X minus 2 equals 0. X must equal 2. So 2 must be the x value that is closest to the origin. Because 2 would give you the point 2 square root of 7. Okay? 1 would give you the point 2 square root of 8, which is slightly bigger. Closer this way, but taller that way. So it works out to be this. Okay? Kind of interesting. Should we do another closest to the origin one? Maybe. Pythagorean theorem this time? Well, Pythagorean theorem is still the distance formula, but yeah, I can do it that way. Okay. So, the origin is 0, 0. Your new point is x, 2x minus 3. So 0, 0. And this point is x that. So the Pythagorean theorem says, well, this side is x. This is 2x minus 3. And we want to know what this side is. So c squared equals a squared plus b squared. Okay. Then if we take the square root of each side, this squared is 4x squared minus 12x plus 9. Or 5x squared minus 12x plus 9. Now we need to take the first derivative of this. What's the first derivative? Well, it's 1/2 times this to the negative 1/2 power times the first derivative of the inside, which is 10x minus 12. So this would give you 5x minus 6 over the square root of 5x squared minus 12x plus 9. Again, the denominator cancels out. 5x minus 6 equals 0. 5x equals 6. X equals 6/5. So 6/5 and 2 times 12/5 minus 15/5 is negative 3/5, I think is where it works out to. but 6/5 is the x-coordinate. All right. Given triangle ABC with AC equaling 8, BC equaling 10, a rectangle is constructed and shown in the diagram. What are the dimensions of the rectangle that would minimize the rectangle's perimeter? All right, so let's make the rectangle x by y. The rectangle's perimeter would then be 2x plus 2y, correct? Okay. Now, so we understand this a little better. I'm going to draw it again like this, okay? It could look like this, 8, 10, and the rectangle could be drawn like this, so but it has to touch, so it has to deal with, all right, now Birchbeck has to think a little bit. Got to remember how to do this one. Because this has to touch, so that changes what the height and length of it is, because it depends upon this, which I'm thinking is to do with the Pythagorean theorem. So where this point is, that point is 8 minus x and y. Because this point, this little part right here is 8 minus x and y. Think. So this point C I might just have to take a break on that one, because I might have to look at that again. All right. Yeah. So before lunch, let's tackle some. And these, I think, are in the second one. I think. So we'll just tackle a little bit before lunch, and we'll come back after lunch, and I will keep instructing to a certain extent.